The last section, I kind of did a problem like this, but nowhere near enough to really get you guys into this. Hey, guys. Hey. All right. Most of us made it back. Let me start off nice. How do you think you would solve this? When you're solving equations, you always do the opposite of what's being done because you're trying to free the x up. So somebody square rooting this poor x, how can I stop that from happening? How can I free the x? What's the opposite of square rooting?
Square it.
Square. So this is a very basic idea of equations. If you do the same thing to both sides, and what thing are you doing? How do you pick the thing you're going to do? Well, what would unbury the x out of whatever the shit it's buried in? So this is buried in a square root. I'm going to square both sides. That should not be surprising. Because the question was, square root of what is 2? Of course the freaking answer is 4, right? Square root of 4 is 2. Okay. So this is only marginally more interesting. So your brain should not care about the fact that this is 3x minus 1. It's just that the x is in here. So how do you get rid of this radical? Square both sides. It's amazing. See, I didn't square both sides because there's an x. I square both sides because there's a square root on my x. There's a square root on my x stuff. I'm going to square. And hopefully this makes a lot of sense. If this is the opposite of this, they cancel. Is that cool? I mean, that's... So then you're left with... I always get somebody that does 3x minus 1 and then somehow the square is still there. And then they square it and they make the problem really difficult. The square died right there. It's dead. Don't mourn it. Right? Square knows what it did. It's time for it to die. And now you've got a really simple equation, hopefully. All right, what do you do? Add 1. Divide by 3. You get 26 over 3. I like it. If you check it, 26 over 3 times 3 is 26. Minus 1 is 25. What's the square root of 25? 5. All right, so that's what I had in the first place. How's this so far? I mean, this is... So any equation. So there are functions you don't even know exist right now, right? There's a lot of functions you don't even know. But if they were in an equation, how would you solve it? You'd have to know the opposite function. You'd have to know what's called the inverse function. Yes?
How does the square cancel the 3x?
It doesn't cancel the 3x minus 1. That's still there. The square is the opposite of the square root. All right, now watch. How do I write square root of 3x minus 1 with a power? What would that be? 3x minus 1 to the... What's the square root? As a power. Square root does what to something? Cuts it in. So what's the power?
2.
No, that's squared. What's the square root? It's 1/2 power. Why does that make too much sense? Because the square root cuts something in half multiplicatively. Or where's multiplication handled? Exponents. So what are you going to put there if it does something in half? 1/2. Right? Let that make almost too much sense. So how do I rewrite this? Like this. And so what do I do when I square this? Well, it means I'm squaring this. What do these do? Cancel! Holy shit! Right? And that shouldn't be a major surprise. Squaring and square rooting are opposites. So if I took half of 3x minus 1, and then I squared that, I get a whole 3x minus 1 back. That's all this is saying. So that bless you, that and that together does nothing at the end. They just kill each other. Right? How do I solve? Well, here, if I had x plus 1 equals 7, how do I solve that? Why do you subtract 1? Because it's the opposite of adding 1. Whatever x is, if I add 1 and subtract 1, I end up with x. Whatever this is, if I square root it and square it, I end up with what it is. They go away because they undo each other. These were simple Because the square root is already by itself. Now, I really want you to see why. If the square root is not by itself, you get it the hell by itself. Right? What did we do with absolute value equations first? We got the absolute value part of it by itself. Right? So it's the same idea here. This is what I call tyrant class. You guys are learning how to be a tyrant. If you have your own country and a radical element pops up, some radical element, we're going to overthrow you. What do? Isolate the radical element and then kill them. Right? And then you're still tyrant. Right? Yeah. What'd you learn in today's school? All right. So here, if I have this, what would you do first? Yeah, you'd add 5 first. Now watch, real quick. Stop. Don't even write what I'm about to write, okay? Don't even write it. If I try to square both sides first, I can't just square this and square that. How do I handle something minus something squared? I have to write it twice and FOIL it. And without really doing that, can you see how the stupid frickin' radical would still be here? Do you guys see that? Wouldn't the radical still be in the middle term? So I squared stuff. I didn't kill my radical, and I just made things look worse. Right? Maybe. Okay, so that's silly. Don't do that shit. So yeah, definitely, if I can get that radical by itself, there'll just be one term, so when I square it, there's nothing to FOIL. I just kill the square root directly. This is why you isolate where your variable is stuck first, because then you can unstick that very directly. Does that make sense? A little bit, no. All right, let's see what happens. So if I add 5, now what do? Now I square it, because now I can directly kill the square root. There's no other collateral damage, right? Dead. So then I get 2x plus 1 equals 49. Subtract 1, divide by 2. Okay, bam. If you check it, what's twice 24? 48. Plus 1 is 49. What's the square root of 49? 7 minus 5 is? Yay! Okay, maybe. Yes?
Can you show us like a crazy one?
Sure. You know it.
Get the easiest reader.
Huh?
We go to the book and it's like...
Don't I always do this? Do I ever not go far enough with my examples? I start off easy as shit, and then I'm like, what about this? 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 And I try to match the level. If I ever don't, call me out on that shit. I don't mean to not show you. We're working our way up there. Something we haven't looked at yet. Here's the next level of this. Can you see why this would be kind of weird? Let's see what you can do, Jeff. You make one that works. It's always nice. Ooh, I like it. Yeah. Oh shit. But is the radical isolated? So then you know what to do. You have to do this. You have to square, because one of your x's is stuck inside of a square root. I can't do shit with that. I have to square. Unfortunately, it's going to make this side become pretty ugly, but oh well. That's crazy ugly. So square. Please, dear God, what mistake have I made? I made like big time. Oh, I'm still wrong. Still very wrong. How do you square something? You write it twice. Yeah. Shit. Is it pretty cool so far? Why did I square? Because of the square root. What's over here? Who cares? Whatever's over there is going to get squared. I have to square. I can't deal with something stuck inside there. Okay, now my stuff is free. I just got to FOIL that bad boy out. There's that poor little middle term you guys are missing. How the shit do I solve this thing? Eventually, what's it not equal to that's supposed to be equal? I got to factor this thing.
You subtract 1.
Yes, subtract 1. And
And
you subtract x because you need this equal to what before you factor it?
0.
It's got to be equal to 0. Oh, shit. Do you see how... I don't care that we learned that in a previous chapter. That doesn't matter worth anything. It's now a tool in your tool belt. I got squared. Ah, shit. Get everything equal to 0. Now, how do you factor that? Eight and 3. They both have to be negative because you got to multiply positive. It had to be negative. So we got x equals 8. X equals 3. Now, do they both work? Let me put the original problem back up there. Why does one of them not work? God damn it. Math. Giving me these bogus... Tell me this, real quick, on the side. So one of these doesn't work. If I gave you this equation, why would you do no work at all? Please, dear God, don't do any work. The answer is, yeah, it can't be negative. So the answer is no freaking solution. I really want, is that cool? Just like absolute value can't equal negative. Square root is defined to be the positive root. How could it equal a negative number? Do I know what x minus 5 is? Is it positive? Is it negative? You don't know. If x is 8, is this positive? Yes. If x is 3, is this positive? So 3 doesn't work. You just don't know it till you get down here. So when you plug a 3 in, 3 plus 1 is 4, square root of 4 is 2. What's 3 minus 5? Negative 2. So, you guys, that's why I get answers that don't work. And here's really why it is. If I square both sides, don't I lose if it was positive or negative? If it's negative and I square it, a real number, it's going to become positive, right? So since I had to square to solve it, I'm going to have these extra answers pop up. They answer the part here, but they don't answer the original. That's before I squared it, was negative. It can't be an answer. So you have to check your answers when you're doing radical equations. Because again, what happens when you plug an 8 in? 8 plus 1 is 9. Square root of 9 is 3. 8 minus 5 is 3. Check. But when you plug a 3 in, you get 2 and negative 2. No good. No, yes. Don't just not write this. You're going to lose points. I need to see you get this and then throw it out. Right? Just like we've done before. Oh, yeah. All right. So you guys try this one. Well, yeah. So this one, I think you should get 2 answers that both work.
5 and 1?
No.
No?
All right, let me catch up to you guys. So what am I going to do to both sides? square, because the square root's by itself, so I can attack it directly. This is the biggest mistake that is made is that weird shit I did over there. X squared plus 4 or something shows up there. You have no chance then. That's not true. So on this side, x minus 2. What do you get on this side? Yeah, x minus 2, x minus 2. So you get x squared minus 2x minus 2x, so minus 4x plus 4. And then, of course, I need to do what?
Subtract the 2x.
Subtract the x, add the 2, so that I end up with a 0 over there. Because then I can do what?
-3, -2.
Good. This is kind of evil. This little guy, 5 and 6, they're evil. Because 6 and -1, or -6 and 1 makes -5, but they don't multiply to be +6. So it's 3 and 2. Ah, shit, you suck. But be careful about that. They're very small numbers, but they actually are really, really hard. So I get x is 3 or 2, and they both end up working, don't they? Try it. It's not that one of them will always not work. Both of them could work, one of them could work, or none of them could work. That's possible. You could get something that has no answer at all. So here, 3 minus 2 is 1. Square root of 1 is 3 minus 2 is 1. It works. And if I make it 2, everything's freaking 0. What's the square root of 0? 0. That works. 2 works when you plug it in. So they both work. You just happen to not get any extra answers. But you still have to check them. Don't just pick one to cross through and hope. Okay. So try this one here. Let's see. Okay, I think so. Make this, make this a 3 there. There we go. Yes, okay. Yes?
Can you explain one more time how you check if it works?
Oh, just plug 3 back in.
Okay.
3 minus 2 is 1, square root of 1.
Okay.
3 minus 2 is 1, square root of 1 equals 1.
Okay.
And when you plug a 2 in, 0, square root of 0 equals 0. How do you check all? You just plug them in. See if it makes a true statement. I like it. Throw it out if it doesn't. Just to make sure everybody's doing the right thing. What do you have to do first on this?
Add 2.
Add 2. Isolate your radical element so you can kill it. All right, you are in control of your country. You're like, you really? You don't like me? All right, well, die. It's not that funny because it's actually happening, but. We start to catch up to you guys. All right, this is where things get a little bit weird. These cancel, right? So don't force anything. What do you always try first when you're factoring? What do you always try first when you're factoring?
GCF.
GCF. It will save your ass. You just always try it first. Just rule it out, right? But here it'll work. What comes out?
X.
So x is 4 or x is... No. What do you make this so that it's 0? 0. If I told you one number times 7, is 0. What do you make the number? 0. Right? So whenever you have an x, GCF x, one of your answers is going to be 0. If I make x 0, isn't this 0 minus 0? Isn't that equal to 0? There's an x everywhere. So if you make x 0, it makes everything 0. It's what's called the trivial solution sometimes. Make everything 0 and you make it work. All right, yay. Do they both work? I know 4 does because that's how I made the problem. So I picked a number and I just made this come out to be 9 and I just made this come out to be 1. So I know 4 works. If you try it, it should work. The 0 work, you can tell very quickly 0 is not going to work because you're going to get a negative 1 on this side. Do you guys see? So you get, if you put a 0 in, you get square root of 1 is 1 minus 2 equals 0 minus 3. Is negative 1 equal to negative 3? No. So it doesn't work. So you throw 0 out and you circle 4. Cool. Deceptively simple. Actually, not even deceptive. It just is simple. I can't. So the basic idea of equations never changes. What changes from your perspective is you keep learning more and more functions. So whenever you learn a function, you have to learn the opposite of that function. So if you learn addition, you have to learn subtraction almost immediately because they go together, right? So if any of you go into like pre-calculus or trigonometry, you're going to learn something called sine. You're going to have to learn something called arc sine, which is like the opposite of that. You have to learn the opposites. Okay, so that's, no, here's the ultimate grossness. How did I make absolute values the freakiest? I put 2 absolute values in a problem. So here's a problem with 2 radicals. Let's see, Jeff. Let's make it work. I'll be so nice if I could make it work. That'll work. All right. So now, let me ask you this. If to kill a radical, I got a square, and I see 2 radicals in my equation, what am I eventually going to have to do? If I kill a radical by squaring, and I see 2 radicals in my equation, I'm eventually going to have to square twice. Eventually. Can you get both radicals by themselves? Currently, isn't he by himself? Well, if I add the 3, I get him it's like whack-a-mole. It's like, God damn it, 3. Right? It just keeps going bouncing. So you just have to suck it up. You got to just get one of them by themselves. Or we got that one by itself. And then you square both sides. Now here's where students really freaking are like, oh shit. You got to square both sides. Which means, I'll do this side. There, I did half. What do you have to do on this side? Write it twice. Foil it out. Do it. Let me catch up to you guys. What's the square root of x times the square root of x? X. Remember that? Remember the whole thing? What's the square root of 7 times the square root of 7? 7. Because what did I just say? What's half of 7 combined with another half of 7? It's a freaking whole 7. So you've got half of x times half of x. You get a whole x. Oh. And then I get negative 3 of them minus another 3 of them. I get minus 6 of them. And then at the end I get plus 9. All right, now, what I'm about to say works with almost any kind of more complicated equation, just pretend like this is where you start. Just pretend like this is the equation I gave you. What do I need to do? What's in this equation that tells me what to do? There is a what piece of this equation. What's in this equation that's new to us relatively? Yeah, what do I do when I have a radical piece of a problem? I isolate it, right? Make it feel all lonely, and then I kill it. Right, we're so evil. So how do I isolate this stupid thing? All right, well, I got to subtract the x's. That's kind of nice because they kill each other. We're dead. I can subtract a 9. That makes negative 18 over there. And what's the last thing I can do?
Divide by -6.
Divide by -6. Yeah. So then I get radical x equals 3. So again, at this step, what was it that told me what to do? I have a square root on one of my variables. I gotta isolate it. Doesn't matter what I did before that. Forget what you did before that. And now, of course, what do I do to both sides? Square. So I get x equals 9. Let's see if it works. It probably does, because that's the number I used to make this. Square root of 9 is minus 3. 0. And what's 9 minus 9?
0.
The square root of 0 is 0. So it works. It makes it 0 equals 0. It makes it true. So it checks. Okay. Remarkably not as horrible as you might think. Let's do the ugliest problem you would see together. All right, let's see. I've got to make this work. Shit. All right. Oh, okay. Let me get some stuff. I'm going to add some stuff in a minute. What did I say? Oh, yeah. All right, that'll work. Yeah, that'll work. Okay, cool. Sorry, I left the room there in case I needed it. So what do I do first here? Yeah, I've got, again, when there's two radicals, you can't possibly get them both alone, right? It's like I don't want to watch my little brother. Well, I don't want to watch him. Well, somebody's got to freaking watch him, right? No, you got to. So either it's got to be over here or he's got to be over here. This is no. So if I square now, at least I kill this radical. But on this side, shit. People sort of give up right here, but it really is not as bad as it looks. So I isolated one of the radical pieces, and I killed it. And now I'm going to isolate the other radical piece and kill it. So now, let's see what we get. What is square root of x plus 4 times square root of x plus 4? X plus 4. Always, that's how it works. This times this is just a whole one of these. Then I get one of these plus another one of these is 2 of these. Is that cool? That's the middle terms, they're like terms. And then at the end I just get so again, it's this idea of, I know this looks disgusting, but the FOIL process, you know how I feel about that, but oh well, too bad. That doesn't give a shit. It doesn't change. You still do this times this, and then combine your like terms. That's what we did. And now what do? Yeah, I got another radical. I got to isolate it so I can kill it, right? So let's see. I can minus x. I can minus 1. That kills that. And then I can minus 4. So I get 2x minus 4 equals 2. Okay, we got a little lucky here, but this number won't always go into these. I could square both sides right now as long as this becomes a 4 times x plus 4. So if this was a 7 or something, don't divide by it and make fractions. You can just leave it there as long as it gets squared when you square both sides. But I can divide by 2, can't I? Everything is divisible by 2. I don't make any fractions. Yay. Go ahead and finish that out. This is another one of those where the whole number cancels. Do you see that? Dead. Man, that's strong. Jeez. And again, what can I do with this? How do I factor this? What do you always try first? What comes out of both? X. So again, you get x equals 5 or 0. I like it. They both work. 5 works because that's how I made this. 3 times 5 is 15 plus 1 is 16. What's the square root of 16? 4. 5 plus 4 is 9. Square root of 9 is 3. 3 plus 1 is 4. So that works. What about 0? I'll plug a 0 in. I get square root of 1 is 1. Over here I get square root of 4 is 2 plus 1 is 1 equal to 2 plus 1. No. So then throw that out. So only one answer, x equals 5. Because 0 makes it not true. Okay. So it really is. The motivation is always, there's radicals. So you can get one of them by himself so you can kill it. Oh, there's still a freaking radical. Okay, I got to get it by itself so I can kill it. You're always thinking to yourself, what is it that tells me what to do? With any problem, you're trying to figure out what part of this problem tells me what to do with it. It's always nice when the math problem is like, hey, dude, do this. All right, so that's kind of like the worst one you would see. That kind of problem right there. Fully agree. It's not that evil. It really isn't. Okay. So let me give you. Let me see what you think about this. Everybody got what they want from this? Okay. I think we looked at a problem like this before. By the way, this is getting to level 1, but do you see how it goes right along with what we were just talking about? How am I going to solve this equation? I have to apply the opposite. And what is the opposite idea? The hidden problem with doing this, how many answers should I get to this problem? Does anybody remember? I've said this a few times. What's the highest power? So I should get 2 answers. And now that we know complex numbers, we know every answer that could happen. So I have to get 2 answers. But if I do this and I just put x as 4, I am not right. I've left something out, because what else squared is 16? Negative 4 is also 16, right? So when you put a square root down, you better put plus or minus to cover your ass, for the other root. So here's the difference between square root of 16 and x squared equals 16. Square root of 16 is 4. There's no question. But this says, what do I square to get 16? 4 and negative 4. Yeah. This is automatically the positive option. Whereas this one has got to have the positive and the negative root as an answer. So when you put the square root down, you better put plus or minus. It needs to become a second nature thing to do. So how would I solve? So here the answer should be plus or minus 4. So how about, so just do this then. Well, yeah, there's square root. Yeah, there's square root. Y squared equals 36. Solve, real quick. Solve.
So negative 6.
Yeah, so when you put a square root down, that has got to be a part of that step. You just automatically put plus or minus. Because we know from a while back that every number, except 0, has 2 roots. The positive and the negative root. All right, what about this one? Be careful, you're smarter than what you might be about to say. No, see, stop that. Stop it. You're smarter than this. Just do it. How do I do it? Same way we did this one, right? To get the x by itself, I square root. Put plus or minus. What is the square root of negative 9? You know what it is. No? Let's break this up. This is the square root of 9 times the square root of negative 1. Right?
Oh, 9.
What's the square root of 9? 3. What's the square root of negative 1?
I.
I. Some of you might not have been here last time, but the rest of you, a little bit of turkey, you're like, what this shit happened? Tryptophan! No, come on. So really, if 4 squared is 16, then 4i squared is negative 16. That's how I kind of interacts with this. So if you got the square root of negative 9, that's going to be 3i. The I covers the negative part of that. It can't be real, because what did we used to write for square root of negative 9? Not real. But now we know what the hell it is. We can't just write that anymore. You can't write no solution or no real solution. I'm like, I still want to see the not real solution. There it is. Maybe. All right, let's step it up. The next level. There's always another level. The next level I'm going to do is just get out of the square root. I'm still stuck on this. Let's make this. Actually, let's make this 1. Yeah, I like it. So let's see if I've said this enough today. What do you think your very first step is? Subtract 5, because where's your x stuck in? It's stuck in a stupid square. You better isolate that thing so you can attack it directly. So subtract 5. And then y is your, sorry. What do you want to kill now? You want to get out of the way. Got a square root to kill the square that my x piece is stuck in. So let me square root both sides. And the minute I do that, I put plus or minus. So I'll do this side. Oh, I'm dead. What do you get on that side?
Square.
2i. Square root of 4 is 2. The square root of negative 1 is I. So real quick, what's the square root of negative 49? 7i. What's the square root of negative 100? 10i. Bam. If you know the square root of blank, you know the square root of negative blank. You stick an eye on it, right? Like googly eyes. You're like, you stick an eye. Googly cyclops. No, all right. Okay, I like it. And then keep going, though. Here's where things get a little bit wonky. Do I have x by itself yet? Nope. So I add 1. Here's how you do this. Oh, okay. 1 plus or minus 2i. And then what do I do to get the x by itself? Divide by 2. So you can either write it like this, or you can write it as 1 over 2 plus or minus I, because the 2's would cancel in that piece, or you can just write it as one big chunk. Right? So you could write this as 1 over 2, give or take, cancel I. Either way. So if you do a problem and the back of the book looks different, they might have done that. They might have just kept going. So notice something. If I have a problem that is written as something squared equals a number, I can just immediately square root and keep going. Right? Even if this doesn't really work too good. So if I had 3x plus 5 squared equals 11. Part of your brain is screaming, 11? But you're like, shut up, Ray, I don't know what that is. So what? I'm just going to have to write it. So what do? This tells you what to do. So what do? Square root. And you put plus or minus. What is square root of 11? I don't know. Oh, good. I can just keep writing it. I don't have to worry about it. Right? So think about it like that. These, so then I get 3x plus 5 equals plus or minus, who knows? And how to get x by itself? Subtract 5. Divide by 3. So that would be a decent place to stop right there, right? Or you can go negative 5/3 plus or minus square root of 11 over 3, but I have to write more for that, so I wouldn't do it. I haven't done one yet. Let me do one. And you're like, you're going to do whatever the shit you want to, John. Well, I'm going to do one where you can do a little more than this. Let me just cut to the chase here. Square root, plus or minus. I'll do this side. Ah. When you get over there. What's the square root of 121? 11.
Subtract 6.
Yeah, subtract 6. Divide by negative 1. Here's the weird thing, you ready? These cancel. Plus becomes a minus, minus becomes a plus, so it's still flipping plus minus, right? Because that's how plus and minus affects with negative. It just becomes plus minus again. That's not good enough, though, and I love my students who are like, where's my plus or minus key on my calculator? What are my two answers? 6 plus 11. So what's that? 6 plus 11 is, and 6 minus 11 is
5. Negative 5.
So, do you see how every other time we've done this, it was something I couldn't do? There was a 2i, and then there was a square root of 11. But if it does come out to be a nice number, you actually have to keep going and tell me what the hell the two answers are. Does everybody see two answers here? Negative 5 plus rad 11 over 3, negative 5 minus rad 11 over 3. There's two answers because it was a squared problem. If it was a cube problem, I have to get three answers and so forth. Forever. Right? Okay, cool. Okay. So, note, oh, yes.
Do we plug it back in and like make sure that those numbers work?
Oh, okay. The radical equations we had, why do I have to check the answers to this? Because there are certain values that can't be square rooted. What is the main thing I'm doing in this problem? Squaring. And what can I do that to? Anything. So you almost don't have to check. You can check just to make sure the numbers work. But you don't have to check to see if you throw something out. You will never throw something out with these. I like it. Good question, though. This one is because it was square roots, and they can't handle certain numbers, so you have to check. Or, they can't come out to be negative, so then there would be no answer then. I like it. Okay. So notice, again, if I had this, that would be relatively easy, right? Can you guys see that and see what you would do? It'd be relatively easy. 9's nice, square root, you get 3. It's going to be nice, plus or minus. So if I have this, do you see what I can do with this? Instead of subtracting 9 and factoring, can you see I can factor this? How would I factor this?
X minus 2.
And then x minus 2, right? So squared. And then it's this problem, right? Do you guys see that? A little bit. Tiny bit. And then I can square it and blah, blah, blah. Right? So you got x minus 2 equals plus or minus 3. You get x is 2, give or take 3. So 2 give 3 is 5. 2 take 3 is negative 1. Plop. So, what the hell has that got to do with anything? I don't know, Jeff. It gives us another way to solve things we can't solve a different way. I could have solved this a different way. I could have subtracted 9, and this is factorable. But it's not always going to be factorable if I do that. So let me show you an example where it isn't factorable. Just for some motivation. Can you factor that? Ain't no way. Numbers that multiply by 2 and add to be 6. No. So the answers are going to be gross. We know this, right? We need to still get them. I can't get them nicely, so I got to get them some other way. So here's what we do. If I add 2 and get it out of the way. Oops, this is S. Can you figure out, let me see if you guys can figure this. Don't say anything out loud. Think about this for a minute, and then I'll get into the whys and what's and wherefores and all kind of shit. Can you figure out, there's a number I can add right here that makes this factor nice. You guys can figure that out. That's a 6, right? So what's got to be here? It's going to have to be, so watch this. Watch. What do you get when you square x plus 4? What are you going to get in the middle? Somebody see what you're going to get in the middle? Well, you're going to get 8x, because you're going to get 4x and 4x is 8x. Right? If I had x plus 5 times x plus 5, what am I going to get in the middle?
10x.
10 freaking x. 5x, 5x. So think backwards now. So if I knew it was 10x, there's got to be a 5 here. If I knew it was 8x, there's got to be a 4 here. I know it's 6x, there's got to be a 3 there, right? Now, if there is a 3 here, what's got to be here?
3.
No?
9.
9. Because what would here, if it was x plus 4? 4 times 4 is 16. 5 times 5 is 25. So the last number has got to be that thing squared. If I add 9 here, I better add 9 there. So this is a process called completing the square. It sounds like a name I would give it. I add something here so that overall this thing factors like something squared. Because then what can I do? What we did earlier. What can I do now? Square root, plus or minus. And then subtract 3 and I'm done. Chapow! So I went from impossible to do to not so hard to do. So let's focus on why this process works, and then break down. There's 2 steps to it, always. So humor me. Do this real quick, and then do this one. Do those 2 real quick. Just multiply them out. Let's get going.